I went to the documentation page for the ESP32-S3 LCD 1.47 version B. I scrolled down to the very bottom and downloaded the demo project for this device. Next, I opened the folder with the demo and launched anti-gravity. I chose the pins for connecting an RGB LED and a Rotary Encoder, and wired everything up on a breadboard. The setup included the ESP, some 1 kΩ resistors for the RGB LED, the LED itself, and the encoder. Then I wrote a prompt to the language model. I told it that the RGB LED is connected to pins 7, 8 and 9 and asked it to run a quick test by turning on each color separately for a brief moment. Notified me it was done and successfully lit up each color just as I requested. It worked perfectly. After that, I gave it a more complex task by adding the encoder into the mix, connected the pins 3, 2 and 0.
If you are wondering how professionals create electronics without chaos and with maximum collaboration, the answer is Altium Develop. Imagine an environment where you eliminate the problem of manually emailing files to others, such as mechanical engineer for PCB verification, and start working in real time in one cloud. Altium Develop is an advanced professional central hub that integrates the PCB design tool with the broader ecosystem. With it, you can forget about the frustration and delays that come from constantly losing context and having to manually track corrections.
And I set the rules. A single click of the encoder should change the active color, and turning the knob should increase or decrease the brightness of that specific color. The model took a moment to think again, informed me it was finished, and displayed the details of the work it had done. When I tested the result, it worked exactly according to my expectations. And honestly, even better. The AI added a really nice user interface with progress bars for the brightness of each individual color, and even included an option to control all colors at once. It turned out absolutely great.